I have given you here a function that has a couple of radicals in it, and I want together to find the most general antiderivative. So what we're looking at here is basically the derivative of a function, and I want to figure out what was the original function. So you could be asked that question as a sentence, the way I have stated it here, or you could be asked it like the Khan Academy did it with Sal demonstrated it using this fancy integral symbol here. So that means take the antiderivative with respect to x. So I'm going to show what that looks like. So this would be the antiderivative of x squared minus the square root, put the square root in here, of x cubed, and I need to indicate what variable I am going to use when I'm doing that antiderivative, and it is dx. So we write that little dx. The way I'm going to do this is use the general power rule in reverse. So the first thing I'm going to do is write these as exponents. So the first variable, instead of with a radical, I'm going to write it as 2 to the 2/3, and then the second one, it's to the 3/2. So now, using the general power rule in reverse, I'm going to take this function, take the exponent, add 1 to the exponent instead of subtracting 1. So remember, we're doing the opposite of taking the derivative. So I'm going to add 1, and then I'm going to divide by that number. So that number right here is this. I'm going to write it as common denominator, so it's 3/3, which means that this can be written as 5/3. So I'm going to divide by 5/3. Then I do the same thing with the next term. I'm going to add 1, so that's 5/2, and I'm going to divide by 5/2. So I have taken the integral, and remember that when there could be any constant there and it would still have the same derivative as this one. So I'm now going to do the last step, which is to simplify this ugly expression, because there's fractions and fractions here, and I'm going to take the denominator in each of these and flip and multiply. So that gives me 3/5 x to the 5/3 minus, flip and multiply, so 2/5 x to the 5/2 plus c. So let's just check this answer by taking the derivative. So if I take the derivative of this, notice it's 3/5 times 5/3 x, subtract 1, so I get 2/3 minus 2/5. So I'm doing the power rule here, multiplying the 5/2, x reducing this power by 1, so that's 3/2, and the derivative of any constant is 0. These cancel, and I end up with what I started with, x to the 2/3 minus x to the 3/2. This is just a check, and I encourage you to do that at least at the very beginning to make sure that you're on the right track. So I've just taken the antiderivative, or the integral, of the function given. So let's move on to a more complicated example, and it's one that looks like it involves fractions. Well, it does involve fractions, but using the quotient rule in reverse is a little bit of a nightmare, so I am going to try and avoid that by dividing each of these by x and rewriting it. And that becomes x plus 1 over x. Now if I want to take the antiderivative of this, in other words, what was the original function if this happens to be the derivative, then I'm going to take the integral of it. The variable that I'm using is going to be x, so I'm going to integrate with respect to x. So the first one is I'm going to add 1 to the exponent. This is a 1 here. I'm going to add 1 to the exponent, so it's x squared, and then divide by that exponent. Plus, this has a x to the 0 here, so I'm going to add 1 to that exponent, which is a 1, and divide by 1. And this one is a little bit tricky. 1 over x, what is that what was you have to think a little bit outside the box here. What was the original function that would produce a derivative that looked like 1 over x? And hopefully you'll remember that it's the natural log of x produces a derivative of 1 over x. Then I still have to add the constant. So I'm just going to simply clean this up a little bit. And now you can double check this by taking the derivative of this to see if you get back to the original function.